I want to talk through a few different ways for us to approach this question. We're given the polynomial 4x cubed plus kx squared plus 35x equals 0. And we're told that this has three roots. X equals 0, which we can see already, because there's a common factor of x that will come all the way out through there. X equals 2.5 and x equals 3.5. If I take a common factor of 4x out of this polynomial, I get 4x lots of x cubed plus k over 4x plus 35 over 4 equals 0. And in this polynomial, we know that this number, 35 over 4, must be the product of the two roots. And this is minus the sum of the two roots. Let's check. 2.5 times 3.5 comes out to be 8.75, and that's 35 over 4. So k over 4 is equal to minus 2.5 plus 3.5. So k over 4 is minus 6, so k equals minus 24. If you wanted to, you could then check that this original polynomial, 4x cubed minus 24x squared plus 35x equals 0, really did have those roots. Another thing that we could do, instead of approaching it that way, is we could look at that polynomial and we could construct a polynomial with these roots. So a polynomial with roots x equals 0, x equals 2.5 and x equals 3.5 would be x times x minus 2.5 times x minus 3.5 equals 0. Expanding out that quadratic term, we get x squared minus 6x plus 8.75 equals 0, which expands out to x cubed minus 6x squared plus 8.75x equals 0. That's a polynomial that has the right roots, but it doesn't have the right coefficients because the polynomial we've been given is 4 times bigger than that. So I'm going to do 4 times all of that polynomial. And that gives me 4x cubed minus 24x squared plus 35x equals 0. It's got the 4 and the 35 that we were expecting. And in the middle here, this tells us that k is minus 24.